Find the area of a figure. You kind of have two things that could happen. You're either going to have a formula that you can use to find the area of it, or you're not going to have a formula, okay? And so we're going to talk about what to do if you have a formula, and then what to do if you don't, okay? So these sometimes will be called total area problems, or they might say find the area of the composite figures. And when they say that, you're essentially finding the area of it, but sometimes the figures won't look normal, okay? And so if you have a formula for it, then all you have to do is use the formula that goes with it. So like if it's a rectangle, you'll use the area formula for a rectangle, base times height. If it was a triangle, you would use the area formula for a triangle, which some people think of as base times height divided by 2. Or you could also think of it as it's 1/2 base times height, or 1/2 times the base times the height. And so if you have a formula, then you use it, okay? But there's going to be some figures that kind of look a little strange, and you may not have a formula specific to that type of figure, okay? So if you do not have a formula for that type of figure, what you're going to try to do is you're going to split the figure up into pieces that you have a formula for. Then you're going to find the area of each of those parts or each of those pieces. And then you just have to add up the areas when you're done, okay? And so let's look at some different examples that might kind of represent those different types of problems. And so the directions will say something like find the area or find the total area. And so you're going to look at the figure. So number one, we're going to look at it and we're going to ask ourselves, do we have a formula or not? And so this is a rectangle because it's a four-sided figure. We got a right angle in there. Okay, so it's a rectangle. And we have to find the area. Well, we have an area formula for a rectangle. Okay, we know by now that the area formula for a rectangle is base times height. So all I have to do is find the base and the height and plug it in and find the area. And so notice, looking at the base and the height, they're not giving us just regular lengths. They're giving us an expression. And so that means our answer won't be just a regular old number. It's going to be an expression, okay? And so we're going to plug it in. My base is 4x, so it's going to be 4x. And then my height is the 2x plus 1. So you're going to take that times the 2x plus 1. And I do recommend plugging them or putting them in parentheses because that'll remind you that if you have to distribute something, that to distribute it. And so notice we have to take the 4x times this. There are two terms in this parentheses. So that means, and there's just one term here, and so that means we have to distribute this 4x to the 2x and then to the 1. So we are going to have to distribute, okay? So when I do that, we got 4x times 2x, so 4 times 2 is 8, and then x times x is x squared. So 4x times 2x gives me 8x squared, and then I take the 4x times the 1. So 4x times 1 just gives me positive 4x. Okay, so that would be the area. Now, talking about units, remember area is going to be square units. And so, like if it was inches, that would be the number of square inches it would take to cover that figure. And so, since they're not really giving me units here, the way that we write this is we put the expression in parentheses. And then on the outside of it, we will put the general word for units, and we put a little square with it. So that means it takes this many, whatever that ends up being, square units to cover that rectangle, okay? And there's nothing else we could have done here because these aren't like terms, and so that would be our answer, okay? That would be the area of that figure, okay? So there's that one. This one, notice, look at the figure, figure out if you have a formula for it. If you do, use it. If not, you're going to have to split it up. And so notice this is a triangle, and we do have an area formula for a triangle. Okay, you can do 1/2 base times height, or a lot of you have told me that you like the base times height divided by 2 formula, so I'll do that one. And so from there, you're going to find your information. So we have to know the base and the height. Remember, the base and the height have to be perpendicular to each other, which means they have to kind of cross at a 90-degree angle. And so when I'm looking at my triangle, if that is my base, then I'm looking for the side that comes, or I'm looking for the height, which comes straight up from it. And so this is my base. Notice that 90-degree angle tells me that that line is coming straight up from it. And so that would be my height, okay? So plug it in. Base is 5 times the height is 2. And then I divide by 2. And then I just have to simplify. So 5 times 2 is 10. And then it'd be over, well, I don't know where that 10 came from. I'm sorry. It'd be over 2, not 10. I think I was thinking of the answer, okay? And so, base times height divided by 2. And all I did is I took 5 times 2, and then I just brought my 2 over. And then 10 divided by 2 ends up being 5, okay? And now we actually do have units here. And so the area would be, it takes 5 square feet to cover that triangle. So it'd be 5 square feet, okay? So that one was kind of an easy one because it had a formula, okay? So now look at the next ones. So this one is a kind of a funky shape, and so that means that we're not really going to have a formula for it directly. We're going to have to do this second part. So if you do not have a formula, then you split it up into a figure that you do have, or into figures that you do have formulas for. You find the area of each piece, and then you just add up the areas to find the total area, okay? So notice this one, it kind of looks like it's a couple rectangles stuck together, and so that's what we're going to split it up into. And you have options. You could, like, if you kind of notice that you could put like a little line right here to split it up into this piece and then this bottom rectangle. You could do that. You could also kind of draw a line going straight down right here. Whichever way makes better sense to you, okay? And so for me, I don't know, I guess I could kind of split it up like this. And so that I have this rectangle right here, and then I have this one right here. And then I'm going to look at my sides and see if I can figure out what the side lengths are. So when you split up your figure, it does kind of cause an issue because you're going to notice that you're missing pieces of your information to be able to find the area. So you will have to find those pieces of information first, okay? So I'm going to work on this rectangle right here. I'm going to work on what is the area, or how would I find the area of that piece, okay? So it's a rectangle, so I'm going to go to the side. So it's a rectangle, so it'd be base times height as my area formula. And then I just have to find the base and the height. So like for this one, I could think about this piece right here is my base. And so if I look across from it, remember opposite sides are equal in a rectangle. So the base would be 3. So that'd be 3 times, but notice I don't know my height. Okay, so I'm going to have to do a little work to find my height. Well, look at the opposite side of it. See if you can get some information from the opposite side. Well, I know from like here to here, it's 6. So like from here to about there, it's 6 yards. But what I don't know right now is how long is this piece, the rest of it. Well, I can actually look at other parts of my figure to figure that out. So like that would be the same thing as this, but also notice this is opposite of that. So this is actually 5 yards. So I'll erase this. So that means from here to here would be another 5 yards. Okay, so from here to here is 6 yards plus another 5 yards. That would all together be 11 yards long. So that whole thing is 11 yards. So that would be the height of that. So base was 3. My height is 11. So the area would be whatever 3 times 11 is, which would be 33 square yards. And I'll just write it in here. Okay, so that's the area of that piece. So now I have to find the area of this piece, and then I can just add them together to find the total area. So we still have to do a little work here, because notice this 8 actually deals with this entire side right here. And so me saying that this right here has a length of 8 would actually be incorrect, okay? And so we're going to have to figure this out. We have to find the area of this rectangle right here, and it's a rectangle, so it's also going to be base times height. But we don't know what the base is. And so, well, let's look at other pieces of our rectangle. So we know this entire thing is 8, okay? But to kind of get just this piece right here, from here to here, I'm going to have to take off whatever this is. Well, if you look, this, remember, was the same thing as that up there. So this one down here, this little piece right here, was 3 yards. So to find this part, I just have to subtract that 3 yards from the total. So this piece right here would end up being 5 yards. Okay, so that's my base, and then my height I actually know because it just goes from here to here, so that's 5 as well. So this ended up being a square, even though it didn't really look like it. So this is why we can't go off of looks here. So the base was 5, the height was 5, and then to find the area, I just take base times height. So the area would be 25 square yards. So that would be the total, or the area of that piece, okay? And then, once you find the area of each of your little pieces, then you just add them up. So now, to find the total area of the entire figure, you take 33 plus 25. And so, we got 33 plus 25, that ends up being 58 square yards. So if we actually covered that thing up with squares that were 1 yard by 1 yard, it would take 58 of them to cover it. Okay, that would be the total area. Okay, so, well, what if they give you a problem where they give you expressions and you had to find the area? Okay, so remember, when they give you expressions, you're not going to normally come up with just a regular number. Okay, but you're going to do it in a similar way that you did here. Okay, so the first thing that you want to do is you want to split the figure up somehow into shapes that you actually have the area for, okay? And so since I divided this one up like that, I think I'm going to do it this way this time, okay? Actually, you know what? It might be easier just looking ahead to draw it vertically. If you look ahead, sometimes you'll realize that it might be easier to do one way or the other, okay? So we're going to find the area of this little piece. Then we're going to find the area of this little piece, and then we just add them up, okay? And so let's start with this piece, okay? So we have to find the base and the height of this piece, all right? So make sure that you realize what the base and the height is. So the base would be like this side, just from here to here, or it's the same thing as that, so we already know the base there, okay? And it's a rectangle, so it's going to be base times height. And so we already know the base is x, okay, so I can actually go ahead and plug that in. And then we have to multiply it times the height. Well, the height would be this entire, all the way from here to here, which is the same thing as this to this, which we already knew. So I already know the height of that one, which is 2x minus 5, okay? So I can go ahead and find the area of that piece. We just have to distribute my x, so it'd be x times 2x, which is 2x squared. And then x times negative 5, which is negative 5x, okay? And then those two won't combine, so that would be the area of this piece. So if you want to write it in there so that you can kind of keep track of where you are, you can, but it's going to be a little harder to squeeze in there. And now we have to find the area of this piece. So the area, that's a rectangle, so it's going to be base times height again. Here's the kicker, though, is I don't have information about the height, which is like from here to here, and I actually don't have information about the base right here. So we actually have to find both of those, okay? So let's start with trying to find the height, okay? So the height is the same thing as from here to here, which is the same thing as just like from this piece to this piece. So I'm going to have to look around to figure out what the height is, okay? So I know, like, from all the way to here, that was 2x minus 5. So what I have to do is get rid of everything except for just that piece. Well, if you look right here, this piece is the x minus 5. So what I'm going to have to do is I'm going to have to take this whole side and get rid of that piece, okay? So I'm going to have to go to the side. I'm going to go up here. I'm going to take 2x minus 5, which is the whole length of this. And I know that because it's the same thing as that. And I have to subtract the x minus 5, which is just this piece right here. Okay, so you have to subtract the x minus 5. Okay, so remember when we did that, we do the keep, change, flip. So we have to change all the signs in this one. So that would be a negative x and that would be a plus 5. And then we combine. So 2x minus x, we get x. And then negative 5 plus 5 would be 10. Okay, so we took this minus just this little part right here, and that way we're left with the height. Okay, so, oh, that's a negative x plus 5. I'm sorry, negative x plus 5, or negative 5 plus 5 would be 0. So we are actually just left with x for that one. I'm glad I went back and checked that. Okay, so that height is just x, and now we have to find the base right here. Okay, so all the way from here to here was the 2x plus 15. To find just this piece right here, we're going to have to get rid of this part because we just want from here to here. Okay, so we got to figure out what that part is. Well, if you look up here, that's the same thing as x. So to find just this part, I have to take the whole thing, 2x plus 15, and subtract out the x, which won't be so bad because 2x minus x, we just get x. And so this piece right here, I'm going to erase my arrow right here. This piece right here would be, well, 2x minus x is x, and then that plus 15 doesn't have anything to combine with, so it just comes over. Okay, so we took the whole thing, subtracted out that piece, which was x. Okay, now we have our base, we have our height, we can multiply. Okay, so our base is the x plus 15. I'm going to put that in parentheses because it's got two things, and then my height is x. And so this is kind of backwards, but we've got one term and we have to distribute it because we have to multiply it. So when I distribute it, it would be x times x, which is x squared, and then 15 times x, which is 15x. Okay, so that's the area of this piece. Whew, we're almost there, so stay with me. Okay, so that's the area of this piece right here. That's the area of the other piece, and to find the total area, we add them. So we're going to take the x squared plus 15x plus, and I don't have to put parentheses because we're adding, but if you want to put parentheses, you can, but we're going to add that to the other area. Okay, combine like terms, so my x squareds will combine. I get 3x squared, and then my 15x minus 5x, that would be a positive 10x. So the area would be this in square inches. So it would take this many, whatever that ends up being, square inches to find the area. There you go.